Hey, selected algebra. So what we're going to talk about today is how to write expressions from words. So if we were in class, we would do this all together. But since we're online, what I might want you to do is just take a look at the screen right now. What words do you associate with the symbols below? Pause for a minute and think about it. Maybe you write a couple on the margins of the notes you're taking and whatnot. All right, so hopefully now you've taken a quick second to do that. Now we're going to talk about what words I'm hoping you've come up with for this. So a plus sign, right? A plus sign kind of makes you think of like the word add or added to. You could say something like more than because you're making it bigger, right? I'm going to make my pen a little smaller so it's a little less like markery. We might say something like the word sum is something you've probably heard in math class before when you're taking the sum of two numbers. We might also just say and. When I'm like 3 and 7 is 10, right? So hopefully those are words that you kind of came up with for the plus sign. For the minus sign, well, that's one right there. You might think minus as a word that kind of fits with that, right? You might also think about subtraction, so you could use the word subtract. We might think of less than, right? Because it's like 7 less than 10 is 3. So 10 minus 7 is 3. We might also have something called the difference. All right, and if you think about it, that like the difference between 5 and 3 is 2. 5 minus 3 is 2, right? Then we move on to division, right? So we might think of words like divided by. One word that you've probably heard in the past, but it's a little bit hard to hold on to in your brain sometimes, is quotient. Right? The quotient is just a big fancy name for the result of a division problem, right? So you might take the quotient of 4 and 2. So 4 divided by 2 equals 2. You might also think about it like split, right? If I had, 9 split by 3, it comes out to 3, right? 9 divided by 3 is 3. 10 split by 2 is 5. So you can think about it that way as well. As for multiplication, you can think about it as multiplied or even multiplied by. Right? You might think of just the word times, like 3 times 5 is 15. Or again, kind of like with quotient, the special word for multiplying is product. Right? When you multiply two things together, you get the product of those two numbers. And then this last one, it's okay if you had a little bit of trouble thinking of, right? The parentheses. So you're thinking about them as parentheses. They kind of group things together, right? So you could talk about it as a group. Or in our case, what we're going to refer to it as is like the quantity. Because a quantity is basically saying like we're taking this chunk of stuff and we want to take exactly what that chunk is equal to, right? So if you want to, again, pause, that might not be a bad idea to write down some of these words on the side of your notes just because we're going to use them as we're going, right? So again, what we're talking about today is writing expressions based off of given information. So again, there's that activity right at the top. That's what we just did. So if I'm writing an expression from this description, the sum of D and 9, right, all I'm doing is I'm looking out for these key words. Right? The sum is telling me that I'm going to be adding, right? So the sum, I'm going to add D plus 9, and that's it, right? If I'm going ahead on the next one, right? Again, we're looking for those key words like we had up above. Quotient is one of those, right? We're taking the quotient of 8 and H. So again, quotient is division. I'm taking the quotient of 8 and H. I'm going to write them in that order, right? However, as you saw above, you don't need to use this little division sign that we've got there with the 2 dots, right? Fractions are just division. So a lot of times you might see this as 8 divided by H, right? You might have it as a fraction. I know the fractions are not everybody's favorite thing, but it'll be all right. When I see you guys in person especially, we'll talk about how to handle fractions, especially this trimester. So don't worry too much. Right. Oy, now things get a little bit more difficult right off the bat, right? So again, we're looking for keywords. Sum is one of those keywords. It talks about adding. And then it says the quantity of, right? So remember I just talked about the quantity kind of being like parentheses a little bit ago? So now we're going to have some parentheses somewhere. And then 8 times x. So times is telling me that I'm going to be multiplying. So this has got quite a few things going on. Talking about the sum of -7 and the quantity of. So we're going to be adding -7 plus some other chunk, right? It's -7 plus the quantity of. So that's where our parentheses are going to come in. The parentheses are going to hold together that entire last piece, 8 times x. So on the inside of there, all I need to do is put 8 times x. And that's exactly what we're looking for, right? So I'm going to kind of expand on this one a little bit. I'm actually going to scooch this a little bit so we have a little bit more room to talk. When we've got something that looks like this, right, it looks kind of like a mess, right? You don't really want parentheses around if you can help it. So let's kind of clean it up a little bit. That -7 can stay the same. That plus sign can stay the same. But then, we were talking about the other day, like back on the first lesson with the parts of an expression, how I think it was 5x is the same thing as 5 times x, right? Those are equivalent to each other. We can do the same thing here, right? If we have 8 times x, we can just write that as 8x. We don't need the parentheses really anymore, right? So if we're able to get to an answer kind of like this, then that's excellent, right? If you get an answer like this one up top at first, that's perfectly fine. There's nothing wrong with that first answer. We want to try and move towards getting that second one, but if we're on the first one still for a while, that's okay, right? We're getting there. So, let's take a look at another couple. Again, looking for keywords is the important piece here, right? We have the quantity of -3 times x, and then add 1. Right, so the quantity of -3 times x, and then add 1. So again, the phrasing of this really kind of tells us where things should go. We've got the quantity of, and then this stuff that comes right after it, 3 times x. So you can kind of think of that going in the parentheses like that. So that's where I'm going to put it, 3 times x in parentheses. And then add 1. So we're going to add 1 on the end of it. Okay. So hopefully it doesn't seem so bad, right? Again, this is a perfectly fine answer. If you wrote this on somewhere, I'm not going to mark it wrong because it's absolutely right. Oops. Except it's absolutely right. Except I forgot this negative sign in there. Whoops. All right, let's pop that in there. My bad. So we got -3 times x plus 1. So again, we can kind of simplify this answer a little bit. That -3 times x is the same thing as -3x written just like that. And then we can have that plus 1 on the end, just like before. Okay, it looks quite a bit cleaner than the answer on the left does, but either one is fine. All right. So if you haven't tried yet, try pausing here. Try this one out on your own and see what you come up with, right? All right, so hopefully you've done that. So here, again, looking for keywords, -6 plus the quantity of 1 minus x. So again, the quantity of, it's making me think that it goes right around those two things. So 1 minus x. So writing that out, right, we've got -6 plus the quantity of 1 minus x. Right? And that is really all we're looking for there, right? We can't actually fix anything else with this, right? This is as simple as this answer can get. We are happy with it just like that, right? Because remember, the only time that we can do that simplification is when we have multiplication, right? So that one up top where we had -3 times x is the same thing as -3x. That doesn't work, right? If I changed this from multiplying into subtraction, we can't do that anymore. All right, so be a little careful if you're simplifying your answers. When we're working on these in person together, if you have questions about when to do that, or if you're not sure if you can do it on a problem, ask me about it. Right? Sometimes we might have problems that have multiple steps like this one. Right? But again, we're going to look for keywords and we're going to kind of give you a hint on how to handle these ones. So there are 2 steps. We're going to take it one step at a time. So step 1, -5 plus the quantity of 4 times x. All right, so let's just worry about that first. We've got -5 plus the quantity of 4 times x. All right. And again, we can kind of clean that up a little bit. I am going to do that here so that our final answer doesn't look super duper scary. Right? But again, if you're at a point where you want a little bit of instruction on how to do that when I see you in person, please ask. Right? So that 4 times x is just 4x. Right? Then, after that, we've got a second step. So what I'm going to do here is I'm going to do it in a different color so that it really stands out. This one says, take the product of -8 and the previous expression, and then add 6. So when it talks about the previous expression, that's what we did in the red, right? That's that previous expression. So if we need to take the product of -8 and that whole chunk, what we then want to do is we want to do -8 times the entire thing, right? So again, when I talked about parentheses, it's like a big group of stuff. -5 plus 4x should be in a group because that's the entire previous expression that it talks about. So we're taking the product, we're multiplying. It's -8 times the previous expression, and then add 6. Last step's not quite as exciting as the rest, right? But this is what we're looking for, all right? What I might suggest is on this one, it is a little bit tricky again, right? But try and pause here. Try this one out on your own and then unpause and see what I did. See if you got it right. So hopefully you did that. On this first part, right, it's the sum of 7 and the product of 2 and x. All right. So it's 7 plus the product of -2 and x. So this is -2 times x. And again, like I've been mentioning, when you have, -2, for example, times just a variable, you can squish them together so that it looks just like -2x like that. All right. We can simplify a little bit more, right? If this step gets you a little like, please be sure to ask about it when I see you in class, right? This one is a little tricky. So because we have 7 plus a negative thing, right, what I can do is I can just ditch the plus sign and have it be -2x, right? Because adding a negative is the same thing as subtracting, right? So again, if that part is kind of like, please ask me about it when you see me in person. We'll go over it a little bit more. I also don't want to be talking for another whole half hour on you on the video. Sorry. As for the second part, right, we have 4 plus the quantity of 2 times, and then again, it's talking about the previous expression, which is everything we had in red. So there's quite a bit going on here, right? We can take care of 4 plus, and then it's the quantity of 2 times that previous expression. So the previous expression, we should group it all up with some parentheses, and then 2 times that, right? If we wanted to be really safe, right, it says the quantity of 2 times that, we could put it in more parentheses like this. I'm going to let you know that in this case, we don't actually need them. Our order of operations is going to tell us to take care of this chunk all at once anyway. So putting it in a big group like that doesn't really actually mean anything. And again, that's one of those kind of tricky rules that the more you practice with problems like this, the easier they'll get. I promise. It's true for a lot of math, is that the more you practice with it, the easier it is later on. Right? I'm not going to say it's fun and easy along the way, but it will get easier. All right, let's take a look at some word problems and see what those might look like in terms of this. Jerry ran a race. He ran 5 miles per hour, and the race took him T hours to complete. We want to write an expression that represents how long the race was. So when you're working on word problems, sometimes they might be talking about a rate, right? Like a speed. So if you're talking about like 60 miles per hour, when you're talking about per hour, that's kind of your clue here, right? Per hour is kind of talking about multiplication a lot of the time. It's not something that, you may have heard in the past, right? So it's okay if this seems a little bit new. He ran 5 miles per hour, and it took him T hours. So this is like saying 5 times T, right? If it took him 3 hours to complete, 5 miles per hour over the course of 3 hours would be 15 miles. And that would make sense, right? If it took him 3 hours and he did 5 miles an hour the whole way, 15 miles total, right? Just like before, this 5 plus T could also be written as just 5T. That would also be a perfectly fine answer. Either one's okay, though. If we've got something like number 9 here, Dave and his friends won $548 playing in a poker tournament. Oh my gosh, the money. The winnings were split evenly amongst the P players. How much money did each player receive? All right, so again, we're going to pull out some important information, right? They had $548 total. The winnings were split evenly amongst P players. Right? So remember, think about what split means. If I split 10 by 5, it equals 2, right? If I split it into 5 equal pieces. If I split 100 by 2, that gives me 50, right? It's like division. So in this case, we're going to be talking about $548 getting split divided by however many players there were, right? Which is P. Right? So we've got 548 divided by P, right? Or, again, we talked about how division and fractions are just the same thing. 548 divided by P that way would also be perfectly fine. In fact, a lot of the time in the future, you're probably going to see it this way, the fraction way, more often than you are with the little division sign. Right? So be prepared to see either one. All right. Dennis made 48 chocolate chip cookies and Y sugar cookies. We want to figure out how many cookies he made all together. All right, so pause here, think about it, see if you can come up with what we might be able to do to talk about all the cookies at once. So hopefully you did that. So Dennis made 48 chocolate chip ones and Y sugar ones. So if I'm trying to talk about the total number, right, think about what the word total means. Right? When you go to a store and they're totaling things up, you're like adding all the costs together. That's exactly what we're going to do here, right? This is 48 and Y, right? If you add them together, that'll give you the entire amount. That's what we're going for on this one. Okay. Oh man, Mr. Noonan. It costs Mr. Noonan $50 to visit the dentist. If you weren't sure, Mr. Noonan's first name is Thomas. It costs Tom $50 to visit the dentist. If the dentist has to fill any cavities, there is an additional charge of $100. If the dentist finds N cavities, how much money does Tom spend? So this one's got even a little bit more going on. So Tom's going to have to pay $50 to visit the dentist. Then, while he's there, if the dentist has to fill any cavities, there's an additional charge of $100 per cavity, right? So every cavity up to N cavities, he has to spend another $100 for each one. So let's think about this one, right? It's going to cost him $50 no matter what, right? He's going to the dentist, $50. Then on top of that, if he gets a cavity, it's going to cost him $100. But that's if there's one cavity. What if he finds another one? Well, then we'd have to add on another 100. But if there's a third one, then we have to add on another 100. And if there's a fourth one, oh gosh, there's another $100. So there might be a better way that kind of represents all of these different situations depending on how many cavities he has, including if he doesn't have any, right? Then it'll only cost him $50. So the way that we can do that is it's 50 plus 100. And then if you think about it this way, right? If he had one cavity, there's just a single 100 there. If he had 2 cavities, we'd have 2 100s. If there were 5 cavities, we'd have 5 100s. Another way to talk about that is by multiplying, right? So this is like having, oops, I don't mean to have that there. It's like if we just have it multiplied by n, by the number of cavities. And again, just like we've talked about a little bit so far, you don't even need the little multiplying there. All right, so let's kind of explore why this one works. So say that Tom has 3 cavities, right? That means that the n is equal to 3, right? It turns into one of those problems we were talking about a little bit last time with evaluating, right? We plug in 3 for n. It's going to be 50 plus 100 times 3, right? So it's like adding on that 100 3 times, once for each of the cavities, right? That'll give us $350, which is a whole lot more than you really want to spend. So brush your teeth. Make sure you brush twice a day. Right? Jim earns $12 an hour for delivering cakes for a local bakery. He worked X hours this week. On Tuesday, he lost $15 because of a late delivery. How much money did he make during the week? So again, this is one where it's kind of talking about a rate. It's like $12 an hour. It's kind of like saying per hour. So that's kind of cluing us in that there might be some multiplying there. He worked for X hours this week, but he lost $15, right? So let's talk about the $12 an hour for X hours, right? Kind of like the one where I think it was Jerry was running the race. That's $12 for every hour, right? So that's going to multiply by X. If he worked 1 hour, he only makes $12. If he worked 2 hours, he'd make $24, right? Because we'd be multiplying it by the hours. After that, right, he made all that money, but then he lost $15, right? So if he lost $15, that means we're going to take $15 away from him. Sorry, Jim. Should have been on time. Right? Hopefully that one doesn't seem so bad. It's not really as much going on with that one as the dentist one, to be honest. There are P players on the Mariners hockey team. Team scored a total of 40 goals this week. One player, Manny, scored 2 more goals than the average player. How many goals did Manny score? So there are P players. Team scored a total of 40 goals. And then Manny scored 2 more goals than the average player. So this one can be a little bit tricky. If you think about average, right? So when you're talking about taking the average, you're adding up a whole bunch of numbers and then dividing by how many numbers you have, right? That is something that we'll get into a little bit throughout the trimester. So if that doesn't sound too familiar, that's okay, right? So again, average is add up all the numbers, then divide by how many you had. Right? So for example, or in this case, right, the team scored a total of 40 goals. If I wanted to figure out how many goals the average player scored, I would have to take that total and divide by how many players there were, which was P, right? If there were, let's say 8 players on the team that played during that game, right? 40 goals split evenly amongst 8 players means that everybody scored 5 goals that week on average, right? We don't quite know how many players there are, so we leave P in there. But Manny did pretty well. He scored 2 more goals than the average player. So we're going to take this average, right? That's what we've got here is the average. And Manny scored 2 more than that, which means all I'm going to do is I'm just going to add 2 on the end, right? So that's actually the end of this one already. I'm hoping I didn't bore you too much, and I'm hoping it kind of made sense. This is not an easy one. I'm not going to lie to you. This is probably one of the more difficult things we're going to do in this unit. So please, 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 if you have questions, ask them when you see me. You're also welcome to send me an email. It might take me a little bit to get back to you, but I will answer. Right? And I will see you next time.